It's very well established that, women are underrepresented in economics and STEM fields throughout the pipeline. Racial and ethnic minorities are even more underrepresented. So we're going to see whether we can use social media promotion to help underrepresented groups on the job market.
That was Yan Chen, the Daniel Kahneman Collegiate Professor at UMSI. And this is Information Changes Everything, where we put the spotlight on news and research from the world of information science. You're going to hear from experts, students, researchers, and other people making a real difference. As always, we're presented by the University of Michigan School of Information, UMSI for short. Learn more about us at si.umich.edu. I'm your host, Kate Atkins. Today, we're doing something a little different, checking out 3 lightning talks from this year's UMSI Alumni Homecoming Celebration. During the event, UMSI faculty shared research highlights that explore trending topics in the information field. We'll hear from Rebecca Frank on citizen-based nuclear disarmament verification, Jiayu Zhao on AI in healthcare and Alzheimer's detection, and Yan Chen on how social media promotion can improve job outcomes for underrepresented candidates in STEM. Before we jump in, a few other people and projects that you should know about. First, UMSI has welcomed 24 new faculty members this academic year, including 8 full-time professors with expertise in areas such as gaming and digital media studies, machine learning for healthcare, and accessibility research. Next, UMSI's 2024 employment report highlights the ability and high demand for its graduates, especially in AI, data science, and cybersecurity, despite a challenging tech landscape. With employment rates above 95% across all programs, UMSI graduates secured competitive roles in a range of industries. Finally, it's bad enough that your image is probably in 1,000 strangers' photos floating around on the web, but now our smart home devices and monitors could be taking photos of us, and who knows where those could wind up. That's why some University of Michigan engineers are developing Privacy Lens, a camera that turns humans into stick figures, the ultimate anonymization. For more on all of these stories, check out si.umich.edu or click the link in our show notes. Now, back to the lightning talks. Let's start with UMSI Assistant Professor of Information, Rebecca Frank, and her talk on citizen-based monitoring and the critical role of trust in high-stakes environments.
Citizen-based monitoring and verification. Can I ask, is that a phrase that's familiar to anyone in this room? The answer is usually no. So, citizen-based monitoring and verification means people who are not governmental actors, who are interested in finding out if state actors around the world are in compliance with nuclear non-proliferation and disarmament treaties. So we are monitoring and verifying treaty compliance, and we're looking to see who's building up nuclear facilities. And they do this in part with satellites. The project specifically is saying people who are using satellite images for the monitoring and verification of nuclear treaty compliance are a really specialized group of people. They are doing something really unique with satellites. They are expert interpreters and analysts of satellite images, and we are interested in them because satellite images are a really unique type of data, and it's a community that in information science we haven't really studied very well, right? So I ask questions in my other research about how people find, share, use, and reuse digital information. And I ask questions about risk and trust. So what are the risks that threaten our ability to preserve information, our ability to share information? How do we decide what information is trustworthy? Those questions become extremely interesting in a high-stakes context like this. So what are we doing in this research project? It is a 3-phase project. The first piece, that machine learning piece, is what the team in Berlin has been working on, taking satellite images and asking, could we fake this, right? So synthetic imagery is like a nice academic word for deep fakes, right? So the question is, how good can we make a synthetic image? And if they are good enough, what could we do with them? So they are doing interesting work, and that's all I'm going to say about machine learning. I am a qualitative researcher. So I am doing interviews, or I've done interviews, and I've done a workshop. And what I have been doing is going to those people who are expert image analysts in the peace and security community and asking them about their work, right? How do you find images? What do you do with them? How do you make decisions about what information to trust? What are the risks you associate with your work? And those have been really interesting conversations. So from those interviews, I'm going to talk about what we've been finding. So when we think about trust in the context of satellite image use for peace and security, what we find are that the relationships with data providers are super important, right? You can't go check the satellite. You can't verify much on your own. So they are really trusting that the data they get from those providers is accurate, is correct, has not been tampered with. And a lot of how they make those decisions about trust quickly are about the relationships they've developed over time with the organizations, with the people who work in those organizations. So the people in those organizations who specifically work with the peace and security community, who provide access to that data, are in many cases also members of the peace and security community who realize the importance of satellite data and went to work for those providers. So relationships like direct, I know you, relationships are super important. The reputations of the data providers are also really important. These are established companies who are committing to long-term business plans, long-term data plans, who are demonstrating over periods of time that they are doing what they say they will do, and then openness, right? So anybody can go and ask for data, right? If you are a researcher or a scholar or a nonprofit, you can have that data relatively cheaply. If you are a commercial organization or a company, it is not cheap, right? But what you get is very high quality. But everybody gets the same data, right? They have one satellite image of that location at that time on that day, and anybody who wants it can have it. They are not taking pictures for only one person. And if you ask two providers for a picture of the same location at the same time on the same day, it should show the same thing. And that is very checkable. So risk. Risk is my big thing. I really love risk, right? The consequences of being wrong when you are trying to decide if someone is violating a treaty and developing a nuclear weapons program when they shouldn't are really high. You don't go to the New York Times and say, I found a nuclear facility, if you are not sure, right? And so the risks inherent in this work were so much more significant than data-specific risks. I am interested in data-specific risks. Those are one piece of a big picture of risky work where we are all trying very hard to keep each other safe, to do responsible work. So we're building up this picture, right? They trust the data providers. The work is really risky. What about that synthetic imagery, right? So if we put those two things together, we really trust the data and where it's coming from. There are super big risks involved. What do they think about synthetic images, right? We put the proposal in for this grant before like DALL-E and ChatGPT, like all of that stuff happened, and anticipated that we were going to be doing a lot of education about synthetic imagery and AI, and then we got funded and didn't have to explain it to anybody. Instead, we had conversations about what's the impact that this is going to have on your work? Are you concerned? Where is this coming into play? There was a high level of awareness about synthetic imagery, about machine learning, about AI. But there was a strong belief across the board that the impact on their community would be minimal because they trust the data providers and where that information is coming from. And so they really overwhelmingly felt like maybe there's a usefulness for synthetic imagery, but it's not a threat to the outcomes of our work.
From satellite images monitoring global security to brain scans monitoring our health, next, we turn to Jiayu Zhao, who's using AI and machine learning to study Alzheimer's disease. Zhao is also an associate professor of information at UMSI.
So today I'm going to talk about this AI plus X. In Rebecca's slides, she crossed out the machine learning part, and I happen to be the machine learning part of that. And then in the past 15 years, I've been doing a lot of machine learning stuff related to AI plus health, right? So consider myself AI X meaning is health. So many of my research I've been doing disease research related to disease. I'm trying to find biomarkers or things that are important to certain disease, and is trying to build this what we call disease progression model. We're going to look at the data, and we're trying to see, in the future what's going to happen, right? And then also, those are preventative, and then those are, trying to discover what's in the past, and in the future we're trying to find the treatment. But today I'm going to just talk about one disease that I care for the last decade. We'll call it Alzheimer's disease, one type of dementia. Yeah, I've been working on this disease for last 15 years, and then it's a very bad disease. So it's a changing, the structure change in the brain, where we have to find out the patterns and block some of the pathways, find drugs to deal with it. Because it's a brain disease, so naturally we're going to work on the brain imaging. Okay, we're going to look at the brain. We're trying to look at a different source of data. We're going to look at medical imaging. We're going to look at the different brain structures, functional connectivities within the brain, and then other kind of biomarkers, genetic factors. Trying to guess, given one patient, we collect all this information. We say, okay, 1 year later, 2 years later, what's going to happen in his brain? What's going to happen in the cognition? So we start with working with a lot of different type of medical imaging, and then we're trying to use machine learning methods, trying to find out its correlation with different parts of the brain. And then more recently, we're gonna what brings me into more human factor as this what we call language markers, right? So one day I'm with my daughter, and then we're in the playground, and we're trying to engage this conversation with the old senior in my community. And then it turns out that I can't just understand what's going on, right? It's not because my understanding of English is because the semantical structures in that conversation messed up quite a bit. So I decided to spend my time looking into those conversations and to see what's going on. And then I met with one hierarchical, which is happened to the Michigan Alzheimer's Disease Center here. We're trying to look at those conversations and say, okay, so is it because some structures changes in the brain? Because of disease and most likely Alzheimer's in this time, that is causing the problem. So we spent 5 years or just looking at those conversations and looking into what's going on inside those conversations. So end up with, getting a lot of work, what we call biomarkers, language markers, and trying to associate that with the progression of the Alzheimer's disease. And then one step forward to get the diagnostic chatbot. So basically, we're building this chatbot, which can converse in a way that trying to quickly detect those language markers that we studied before, and then trying to make quick diagnosis. So see, before this behavior type of treatment, imaging type of detection is the major way of detecting dementia. So we basically go to the clinic, we do some cognitive tests, take a MRI scan, and we know what's going on with the brain. But before you do that, there's no way for us to say, hey, you're going to have this risk for dementia. So we build this chatbot. This chatbot is trying to communicate with the patient and trying to come up with a risk score very quickly of how likely this patient is going to develop into MCI in the future. We are trying to use large language model to build a chatbot so that the chatbot can follow some kind of clinical protocols to have conversation with the seniors in a way that is cognitive stimulating. And then after a certain period of conversation, we can show that it's going to slow down the progression of the disease over time. So there's some ongoing work, right? So we just have the manuscript published. And then we also have the treatment part of that, we believe that multimodality can actually help us for this scientific discovery. So basically, when we're trying to look for some new treatment, look for some new molecular structure for some new drugs, the way we do that, we used to do that was trying to find the specific molecule structures, and then using the data, and we do experiments, and then we're trying to find what's in the data, and then to show that the molecule is really functional, right? So this is what previously people do. When it's not working, and then we're going to go back to the data, and we're going to do more experiments with trying to change the molecule structure a little bit, and then trying to do the experiments again to see if the drug is effective or not. With this multimodality, is very similar to the ChatGPT, GPT-4o, right? So with this kind of multimodality reasoning, what we can do is, what we are actually doing right now is that we put this experiment data and the domain knowledge all together using some unified knowledge integration framework. And then we're trying to plug into the natural language as well. And then with the help of that, basically someone can sit in front of the computer and input this molecule structure into, or say, ChatGPT, and say, hey, how do you think about this with this disease? So through this way, like human experts is involved in the scientific discovery process using the natural language, not by diving into the data again, but just navigating through this large language model.
Moving on from health to the job market, Yan Chen will walk us through how social media promotion can affect job market outcomes for underrepresented groups, particularly in STEM fields. Chen is the Daniel Kahneman Collegiate Professor at UMSI.
So we know that social media is used by academics to promote their own and others' research, and and it's also correlated with citation counts, which academics cares a lot about. It's a proxy for influence. But we don't know the causal impact of social media promotion on academic success. And for those of you who have taken causal inference from Professor Cohn and experiment design, you know that correlation is not the same as causation, and the gold standard for established causality is to run an experiment. So this is what this paper is about. And so the practical problem that we try to solve is the underrepresentation of women in STEM fields and also in economics. There are a bunch of references about, it's very well established that, women are underrepresented in economics and STEM fields throughout the pipeline. Racial and ethnic minorities are even more underrepresented. So we're going to see whether we can use social media promotion to help underrepresented groups on the job market. One question is, can social media promotion improve job market outcomes for the, JMC is short for job market candidates? The second one is whether it can be used as a tool to increase diversity in economics. So we conducted the field experiment on Twitter in the 2022-23 job market. So the one feature about the econ job market is economists created and organized its own market. It's very structured, and it's a relatively thick market. So we prepared the subject pool in September and October, then did a pre-experiment survey, and then we did the intervention in November and December. Then we collect the outcome variables from Twitter and also a year later from the job candidate themselves to see where they ended up. So the way we did that was we contacted 2,700 job candidates. These are PhD students, and created our own Twitter account. It's called Econ Job Market Helpers. And we grew it. We asked actually all our friends and colleagues to follow it. So I had more than 2,000 followers by the time of our experiment. And we also invited economist influencers with more than 4,000 followers. And, for our sample, the average number of followers was 20,000. So it's very much right skewed. And the average number of Google Scholar citations among our influencers was 21,000. So these are really important scholars in the field. So we first survey the job candidates and ask them to summarize the job market papers in a tweet. And we coach them on how to write an effective tweet. Then we randomly assign them into a treatment group and a control group. We match the treated job market candidate with an influencer in their field based on the cosine similarity of their abstracts and the influencer's top 30 papers, most influential papers. Then the influencer quote tweeted their job market tweets using customizable templates. Then we send a post-job market survey, and the compliance rate was pretty high, 80% response rate. The first result is on visibility and engagement using Twitter data. So the control group on average got about 900 views and 4 likes on our account, the research account. The treatment group was doing a lot better, okay? So the job market tweets of treatment group received 4,000 more views. That's like a 400% increase over the baseline. And, 12 more likes, that's a 300% increase on Twitter than the control group. So does it work in terms of publicity? Yeah, and the effect size is huge. And now for the real thing. So the job market has interviews at the conference. These are 30-minute interviews. And then on-campus visits called flyouts. And the third one is job offers. So the control group gets about 5 flyouts. And the treatment group gets, on average, 1 more flyout than those in the control group. So the effect size is also large compared to the baseline. And the last one is about job offers. So in our control group, job candidates were getting on average 3 job offers. And in the treatment group, they get 1 more. They get 0.4 more. And that's marginally significant, so which means it's significant at the 10% level. In terms of aggregate outcomes, the control and treatment groups are actually not that different. So 92% of both treatment and control group got a job at the end. In terms of tenure track positions, they get about 50% of them got a tenure track position. Treatment group also are more likely to secure a job at top 30 institutions, but the difference is not significant. So can social media promotion be a low-cost and scalable tool to help job market candidates and underrepresented groups on the labor market? It has a huge effect on publicity.
Thanks for listening. To learn more about upcoming events like this, visit umsi.info/events. And make sure to subscribe to Information Changes Everything wherever you listen to podcasts so you never miss an episode. Before we go, UMSI hosts important dialogues like this all the time. Get connected to upcoming community gatherings, scholarly events, and degree program information sessions at umsi.info/events, or head to the link in our show notes. The University of Michigan School of Information creates and shares knowledge so that people like you will use information with technology to build a better world. Don't forget to subscribe to Information Changes Everything on your favorite podcast platform. And if you've got questions, comments, or episode ideas, send us an email at umsipodcast@umich.edu. From all of us at the University of Michigan School of Information, thanks for listening.